Hello and good evening, everyone. My name is Himanshi and I'm an engineer by profession. I recently graduated my master's in data science and engineering from DOE. The presentation that we're doing right now is closely related to the subject matter of my thesis, but it's developed with the objective of engaging conversation to a more general audience, so it's not very technical. It's about bias and fairness in artificial intelligence and automated decision making. So how do the existing biases within data sets and real-world observations come into the picture when we're talking about automated decision making, and how do they affect those decisions? Fairness, in principle, is a very age-old problem. So in the technical context, there are many different solutions to it, but in a societal context, it's still a very old problem, and there is often a lack of consensus to what actually counts as fair, because different people could have very different philosophical ideologies, they could have different cultural conditionings, different set of experiences that shape their opinions about these things. And that's why I want to start my presentation on this quote by Aristotle, who was a Greek philosopher and thinker, because he wrote a lot about justice as a virtue. So his core principle in the things that he critiqued in people's philosophies and political styles was that justice is inherently, it's a virtue of human beings and of society. And so he shared one of his principles, which is that there are some things about which it is not possible to pronounce rightly in general terms. The raw material of human behavior is of this kind. And if it doesn't make sense to you, it's kind of not supposed to, because it's really vague. But we'll come back to this at a later slide to discuss it. So the outline of my presentation is as follows. I will present an example of how data analytics is used in real-world applications, and what are some serious applications that could have adverse impact on individuals and society if special care is not taken, that these methods are not reinforcing existing biases in society. And then I'll talk about notions of fairness in algorithms and what kind of contentions they can lead to. We'll formalize another idea of counterfactual fairness, which is a really interesting direction to which the technical fields are now making advancements. And then we'll open up the discussion to individual fairness, which is a general individual fairness, which will also be discussed in, after this presentation. So recommender systems, all of us use these apps. Netflix and Spotify are using your data based on your history of consumption of content, and using that to kind of recommend more content for you to consume. Similarly, there are product recommendations on Amazon or Bol, which will look into what kind of products you've bought previously and then make recommendations based on that. And there's also content recommendation in Twitter and Facebook. By now, because of GDPR, there are stricter rules as to which data can or cannot be used, and when you have to ask for permission from people as to what data you want them to use or not. And as far as these recommender system goes, it's quite innocent, because it's being used to sort of serve personalized content to you, and it's not really affecting society in a really adverse way. But when we talk about automated decision making, there can be a lot of bias within the data sets, because the data sets are nothing but real-world observations, and real world is prejudiced, it's biased, and there are not a lot of ways, there are a lot of ways to define these biases, but not a lot of ways to capture them in the machine. So for example, there is a software called Compass, which is in use in the United States. It's a risk assessment tool for criminals, which assesses people in terms of how likely they are of committing a crime in the future, given that they have committed certain crimes in the past. And there was a study done on this software which said that this software is biased against blacks. There was a huge to and fro between the people who built these algorithms and the people who did this study, in which they were fighting with each other based on different notions of fairness. And we'll discuss that in the next slides. And this other example of bias in automated decision making is related to loans and lending services being denied to people based on their race. And this is different from the first example because it may not be intended. For example, if your data is being used to calculate your mortgage, your loan, your credit scores, and that data includes your zip code. In the US especially, zip codes and areas are segregated based on communities and demographics a lot. So if that attribute is being used to make a decision on whether or not you should get a loan, then chances are that you are being discriminated against on the basis of these demographics. And about the Compass debate, there are two different notions of fairness in this particular debate, but in general there can be many, many different notions of fairness. But this specific case it's quite interesting because it actually shows us one of the biggest fallacies of algorithms and why they should be made more explainable and why data should be made more explainable before we can start using them in these real-world applications. So these two notions of fairness are equality of opportunity and calibration of odds. They both mean different things, but they might resonate with different types of people for what counts as fair. Equality of opportunity is that there should be a level playing field for different demographic groups. So, for example, the amount of errors in prediction, like the false positive rates and false negative rates for each group, should be same for the predictions to count as fair. Now, that's one notion of fairness, but another one is calibration of odds, which means among defendants with a given risk score, the proportion who would reoffend if released is the same across different race groups, which also kind of makes sense, right? Now, if there is a representation bias in the data, then what happens is that that certain groups are not represented well enough. For example, in this case, if we talk about the income data set or census income data set, there is a very clear difference in representation of African Americans and Caucasians. You can see that the disparity is even greater if you take into account the number of positives and number of negatives, which is orange and blue. And these kind of problems can be easily dealt with certain algorithmic solutions. For example, one intuition behind a solution is to assign weights to these observations based on their relative privilege. So, for example, if you are from a privileged group and you have a positive outcome, you get a lower weight than if you are from the privileged group and you have a negative outcome. And also for the protected group or for the unprivileged group, it's the opposite. So based on your relative privilege, you get assigned high or low weights. And that works for this problem. But when it comes to a problem in bias in society and in how distributions can change with your race or with your demographics, that is harder to mitigate with algorithms. An example of that would be, again, in the Compass example, where you have race, you have offense, and other attributes like your prior arrests or your juvenile arrests. So based on your race, whether or not you got arrested could also be affected. So in specific areas in the US, for example, there is a lot of police attention, whereas in certain other areas there might not be that much police attention. And so the base rates of how the outcome changes with your race, the distribution is completely different for different races, because the processes involved in collecting these data themselves are biased. So there is bias in the data generative process itself. And what happens in this situation is that your outcome itself is unfair. You don't know what the fair outcome even is. So how do you design algorithms in such a problem when you don't even know what the right outcome is? Going back to the previous slide, these two definitions of fairness have been used in the Compass debate, but it turns out that the base rates are different. So if we look at the cause and effect of how the data is actually generated, neither of these notions actually make sense. So even if you don't understand this, it's okay, because it's irrelevant, because the outcome will still be unfair even if these metrics are fulfilled. So based on my research, the main conclusions that I had were, first of all, fairness trends of algorithms are different for different types of biases, which was kind of an obvious assumption that I started with. But I didn't find any studies which talk about mitigating fairness in AI with respect to types of bias present in the data set, which I think is so important, because the next thing that I found, using these methods that have been used in certain contexts, but using them in other contexts, I found that the scores of fairness would go up based on those metrics that I discussed before. But what can happen then is that to make equitable decision-making for an unprivileged group, you're actually taking away the fair opportunities of the protected group. So they're creating this illusion of fairness by taking away fair opportunities from individuals of a privileged group and giving them to people of an unprivileged group. And that's not how equity really works. Equity should not come at a cost of the justified opportunities of the privileged. Equity should be defined based on your own experiences and your own relative disadvantages in life. And that's why this is such an important issue to discuss for not just technical communities, but for in a societal context, because automated decision-making is something that's going to impact all of us at some point. The real-world applications of it are increasing. And with the new GDPR regulations, the kind of problems that that's presenting is even more adverse, because there's not a lot of clarity on what is to be expected, and there's a huge disconnect between social scientists and the technical communities. Another thing that is relatively unexplored that I found is the intersectionality between race and gender. So for instance, in the previous example, if you also account for the gender of the person and you try to mitigate unfairness based on race and based on gender, most of the methods do it separately. They don't really account for the intersectional subgroup. So for example, if you are a black woman in the Compass debate, then as a woman you have an advantage. You are a privileged group compared to the men. But as a black woman, you're disadvantaged because you're black. So in one respect you're advantaged, but in the other respect you're disadvantaged, while in reality, the truth might be that you're actually disadvantaged in both. And these kind of things are not something that algorithms are really thinking about, or people in the communities are really thinking about. But at least when it comes to finding out how to make algorithms more fair for individuals, One direction is of counterfactual fairness, and what counterfactual means is to imagine a hypothetical situation. So for example, if everything else was the same but my race was different, would the outcome change? Now this kind of thinking is primarily, it's inherent in human beings, the sort of future planning, and it's not something that algorithms are designed to have. But there are people who are making advancements in counterfactual fairness and algorithms, or at least counterfactual explanations as to what could have happened if certain attributes were changed. Then that can give us a better idea of how the ground truth, how the actual reality is within the data, what kind of biases are actually there. And finally, individual fairness in general also encapsulates individualized treatment. So even if we had counterfactual fairness, and if you were to say that similar people should be treated similarly, that still wouldn't be the individual notion of justice and fairness. And that's exactly what Aristotle wanted to capture in one of his principles, that individuals, humans, are not meant to be treated as equals because we're all different. We all have very different experiences and very different lives. And it's impossible to use machines in that sense to truly provide individual justice. And with that, I will open this panel for a discussion on this specific topic of individual fairness. And we would love to hear your thoughts about what fairness means to you and how can you be part of this conversation about fairness in the future for policy making and lawmakers. Thank you.
Hey, you're still here. So you like the video. If you want, subscribe and click the bell.